Hello and welcome to all participants connected from all over the world. My name is Sophie Hoheisel and I'm Product Manager in Energy, Mining and Sustainability at the German-Chilean Chamber of Commerce. And I'm very excited to moderate this webinar on post-mining, trends in innovation, collaboration and value creation today, which is part of the activities we are organizing in the framework of the German Mining Network. The German Mining Network is an international platform which is comprised of 8 competence centers for mining and raw materials of several German chambers located in countries rich in raw materials. Other members of our network are strategic national and international partners such as the German Mineral Resources Agency, Germany Trade and Invest, the Association of German Chambers of Industry and Commerce, and RWTH Aachen University. The Federal Ministry for Economic Affairs and Climate Action funds and supports the activities of the network. There are also other institutions and associations that are involved in our network, and I would kindly invite you to visit our website, germanmining.net, where you can find further information, contacts, and in addition, you can sign in for our news ticker. Today's webinar is all about post-mining and collaboration. Post-mining and legacy issues present challenges around the globe that can be turned into opportunities for new ventures, collaborations, and innovations to create value from waste and contribute to sustainable and circular mining practices. Against this background, this webinar will present current initiatives from around the world that are bringing fresh ideas, tangible innovations, and new forms of collaboration to the field of post-mining. But before we start with the first presentation of today, I would kindly ask you to write down your questions and comments in the chat. And at the end of all presentations, we will have a session to answer and discuss all your questions. But now I have talked enough and I would like to give the floor to our first presenter of today, Dr. Krump, who will introduce us to the project RECOMINE, a regional alliance from the Ora Mountains in Germany. And this project is working on finding new solutions for places affected by the mining and metallurgical industry pollution. Dr. Krump, we are excited to learn more. Please turn on your camera and microphone and go ahead with your presentation.
Yes, hello. Can you see and hear me?
Yes, but we don't see your screen.
Well, one moment, please. Can you see now?
Yes, but in the moderator view, you have to switch to the presentation mode. Anzeige Einstellungen.
Yeah.
Now you stopped sharing your screen.
This will, so.
Yeah, perfect.
Okay. Yeah, thank you for your introduction and welcoming me in your webinar. As you most probably read from the invitation, my colleague, Mr. Wibbling, was supposed to hold this presentation, but he has been infected by Corona and is in ill holiday at the moment. So I jumped in on short notice. I want to apologize in advance because it's not my presentation I'm going to hold here. What we want to show you is one project which is currently supported by the RECOMINE research network, which we are going to carry out in southern Germany, southeastern Germany, with an old tailing in order to characterize the metalliferous content of it. The synonym for the whole project is NIRUBIS, which is an abbreviation of German wording. The English title would be, in full length, High Resolution Characterization of Mine Tailings with Real-Time Technologies for Environmental Hazard Assessment and Economic Evaluation of Resources and Reserves according to international standards, as a basis for sustainable secondary mining and environmental rehabilitation. In the Ore Mountains, which is the area for our research, we have a lot of old abundant mines and a lot of old abundant tailings which have been closed in the 60s, 70s of the previous century. Some of them are still older. And of course, nowadays, with a new focus on strategic metals, this becomes interesting from 2 points of view. On the one hand, there is a metal content which has value, which might become very interesting today with increasing metal prices. And on the other hand, we have a potential contamination of groundwater and other sources, which we want to mitigate. And once we find a way to, let's say, to mine or remine this old material, we can solve both problems. That is actually the way where we come from. Our consortium, consists out of 3 partners which are going to carry out the research project. This is at first GLU, that's my company, Geologische Landesuntersuchung, with 2 partners called GTAI and Erzlabor. Our approach combines proven technology for a new approach. That means we are using a technology which has been developed for the detection of contaminants in environmental economics. And we are combining it with the international way of the definition of a resource. Means resource estimation according to the PERC standard, which is the European standard comparable to York or NR43. The aim of such a standard is to define the financial value of a certain resource, normally assigned to natural deposits for metals. And of course, such a research begins with collecting of samples, collecting of data, usually drilling, and in order to collect data about the content of a certain deposit. And with the increase of data, usually you increase the level of confidence. You can see this graph here. We usually talk about inferred, indicated, or measured resources. Once we have measured resources, we have proven on a statistical way a certain content of a certain element in a deposit, which is actually the base for the calculation of mineable resources. That is actually the way how it works, usually for primary deposits. And once you have such a resource estimation according to the standard, it's a so-called bankable document, which is accepted once you are, for example, want to go and mine that stuff as a security at the bank. So that is how it works, usually for primary resources. And our aim now is, and the target, the goal of the research project is to adopt that for secondary deposits as a mine waste disposals, or especially tailings. And such a characterization of a resource is usually the first step in the value chain for other remining or data acquisition works, and it actually is a quantification of the valuable elements or pollutants in a tailing, which is the basis for a feasibility study. And this is actually the approach. And in order to get to that goal, we are going to apply digital data acquisition in real time. That means we are not going to drill holes in the tailing, taking the samples to the laboratory, doing X-ray fluorescence for the definition of the elements, and then come back and create a model. Our approach is to push by hydraulical means a probe into the deposit or the tailing in order to measure by X-ray fluorescence the elements in situ. That means without taking a sample. And that is actually the way it works. We are going to use a specific tool for it, which is developed by our partner Geckotech. We call it a metal probing tool. And with that window here and the interior of that tool, we have the opportunity to measure the elements by X-ray fluorescence inside of the tailing. We combine that tool with a classical cone penetration tip at the lower end. This tip measures the mechanical parameters of the sediments we are going to probe. That is actually a technology which comes from engineering geology or construction and is called cone penetration testing, which is getting used in order to test soils for foundation design. Why do we combine that? With the X-ray itself, we are going to measure the chemical content of the deposit or of the tailing. With the cone penetration tip, we are going to measure the mechanical parameters of this deposit. By using the friction ratio of the mechanical parameter, it is possible to determine the physical parameters of a sediment, means grain size distribution and facies. Why are we going to do that? Usually the theoretical approach for the statistical identification of a primary deposit like a hydrothermal impregnation is to accept the whole deposit as a black box under the assumption that the content is continuously increasing or decreasing when you with increasing distance from the source. That is how the mathematical approach is usually getting used. But here we have an anthropogenic sedimentological deposit, means the chemical content is not increasing or decreasing continuously in a certain direction, but is dependent on the internal structure of the tailing. And this structure is dependent on the history by jetting in the material in different loads from different directions. So a long speech, very theoretical, but that means that we could have a change in the grade by when crossing different sedimentological horizons. That makes it special. So here you can see that again, the tool, how it works. We are pushing in that probe, measuring the geotechnical parameters. We are measuring by XRF the in situ concentration. This little picture shows you high concentration in red and blue concentration, low concentration in blue. And by doing so, we get in situ the data of that tailing, which is shown here in the picture. Of course, we have to take care that we are using an equidistantral grid as we do it in the investigation and exploration of primary deposits as well. So that is actually how it works and how it should work on that example in the Ore Mountains. And by doing so, we still are going to drill or push 2 sampling holes in order to get some real data for the classical analytics in laboratory in order to calibrate our probing tool. Once we have these data, we are trying to derivate the soil classes by using the mechanical and physical data. So what is shown here in green, blue, and purple blocks is something what we call the inner geometry. This is not the same as we would derive from the chemical data, but it's depending on the history and the sedimentological history of the tailing subbody. It's like a sedimentological deposit, because as only when we understand how that tailing is structurized internally, we can use the geostatistical approach within mapped blocks. So it's a little bit different than the classical approach for a primary ore deposit. At the end of the day, we are going to create a 3D model from this data, showing on the one hand the physical sedimentological characterized internal structure, and within these substructures we are going to apply the classic geostatistics and variography in order to reach the right level of confidence about the content, which is necessary for the resource classification. At the end of the day, we are going to, once we have done that and we have reached a comparable level of confidence within the internal structure, we can expose the so-called block model, as you do it in classical mining as a base for reserve estimations. So this block model shows now different colors the grade or content for a certain pollutant or valuable material. It doesn't matter whether it is copper or arsenic, which would be two examples. And at the end of the day, we have such a block model for the valuable material, for example, copper, tin, or zinc. On the other hand, we can use it in order to show at the same time, with the same principles, the level of confidence for the distribution of a pollutant. And that allows us to tell at the end of the day where is what in which concentration. For the valuable model, we can apply then the principles of the resource statement, and at the end of the day, we will receive a resource model which allows us to define the valuable content. Means at the end of the day, once we can remine that material, it has a value of X, Y, Z $1 million, which is necessary for any feasibility which is supposed to follow. Once that has been done, and that was actually the aim of our project, using the statistical approach, the international standards, and the innovative in situ technology, we have it. And then in the next step, we can apply different ways of in situ bioleaching, for examples, and we have the actual economical base for a feasibility study of remine such a tailing. That is actually our project in a nutshell. And of course, as you can see, it takes several steps until we reach the goal. And we are going to start the fieldwork for that project on the shown tailing in May this year. Thank you very much for your attention.
Thank you very much, Dr. Krump. There's a few questions that are directly pertaining to the presentation, so I will take them now and then we can go into a more deeper discussion on the Q&A session. So one question was, how deep can the tools go in measuring the metal content?
Of course, it depends on the relative density of the tailing itself and the water content and so on and so on. But by experience, we can say we can reach 30 to 40 meters easily, because the material is mostly, in many times, water saturated, and therefore it is simple to push with such a tool.
Okay, thank you. And how does humidity affect the semi-quantitative results?
Please say again.
The humidity, die Feuchtigkeit, der Feuchtigkeitsgehalt, does it affect the results?
No, not at all.
Okay, that was one question. And what material is the cone made of? Like the tool that you're using?
Stainless steel.
Stainless steel. And is there any regulation that you use in the manufacturing of the tool?
The tip itself, which comes from the construction industry, is standardized in DEN ISO 22476-2. So that is a standardized tool which we're using for construction, soil foundation design any day. But the tool behind, with the XRF, is actually not standardized. It has been invented by our partner GTAI, and I'm pretty much sure they have a patent on it. I do not really know it, whether it has been already patented or it is in the process, but that is not standardized. This is brand new and is subject to such a patent procedure.
Great, thank you very much. In the interest of time, I think we move on to the next presentation, but there might be more questions, and then we have the Q&A session, and also you'll be participating in the panel discussion, so we have a chance to get into a few more detailed questions then. Okay, thanks a lot. I give over to Sophie for leading into the next presentation.
Thank you, Arti, and thank you, Dr. Krum, for your interesting presentation. We will see you again at the end of the webinar for a Q&A session and panel discussion. And now I would like to introduce our next speaker, Professor Fiona Haslam Mckenzie, Program Leader for Regional Economic Development of the project CRC Time in Australia. The project aims to drive transformational change and enable regions and communities to transition to a prosperous and sustainable post-mine future. Welcome, Fiona. Please go ahead with your presentation.
Thank you, Sophie, and thank you, everybody. It's my pleasure to present this information about the Cooperative Research Centre for Transformation in Mining Economies, which we call TIME. Unfortunately, the Chief Executive Officer of TIME, CRC TIME, Dr. Guy Boggs, is also unwell with COVID-19, so it's my pleasure to introduce this program that we have been in operation since mid-2020. The Cooperative Research Centre is funded for 10 years, and we have a responsibility on a national scale to achieve workable post-mining options. And as many of you know, mining is a very important industry in all states of Australia. And it's difficult to understand exactly how many mines will be on the cusp of closing or are closed or even abandoned, but it's probably up around 100,000, the number of sites that are either abandoned or will close in the next 10 years. So the consortium is 77 partners, and that's consisted of mining companies, Australian state and territory governments, local governments.
Fiona? Yes. Fiona, did you want to share your presentation? Because it's not shared yet.
I'm sorry.
No problem.
My apologies. Let's go back. Sorry.
So you go on share screen on the green button.
Yeah, I'm sorry. I'll go back.
No problem. And you can start. Yeah. Cool.
Yeah.
Perfect.
Thank you. So the consortium is 77 partners. It's mining companies, governments, local governments, community and regional organisational representatives, Aboriginal and traditional owner representatives, and they are particularly important because in many cases, particularly operational mines, mining operates on their land. So they're a very important stakeholder for deciding what post-mining opportunities there are. We also have non-government organisations and university researchers. Importantly, the Cooperative Research Centre programs are sponsored, 50% sponsored by the Australian government. So it truly is a national program, and it's very much oriented to practitioners and what practical solutions are there to post-mine futures. So now we know that in Australia, and which is similar to other places in the world, mines are not commonly relinquished. Often they are either put into care and maintenance, or they are in many cases abandoned, although in Australia we now have fairly tight regulations that are working towards legislating against that. But actually planning for post-closure and for a future that has some use, whether it's a benign use or an economic use, that tends not to be terribly well planned for. And there's a whole range of reasons for that. And that's part of the remit of the Cooperative Research Centre, which we are a part of, to try and unknit some of those difficulties and to really understand where the blockages are, but also to identify opportunities to enable progress that is satisfactory to, or acceptable, perhaps is a better way to describe it, to key stakeholders. So our job is to bring together those diverse stakeholders to try and establish practical ways to achieve that. Strategic goals are very clear. We have access to consultants and commercial opportunities. We have opportunities to intervene in the mining cycle. We have the opportunity to test some of our research and some of our ideas working with communities and people living in those communities about which we are researching. And we have the opportunity also to undertake some of our research ideas in abandoned mines. We have 8 different priorities. And this research program is a little bit different in that people are at the centre of it. Unlike many other research programs that have looked at mining in the past, it's been very much about the technology and the hard sciences. While that is definitely a part of this research program, it's very much how it applies to people and places. So spaces, places, people and time. We are very much also focused on understanding the regulatory environment and the legislative processes which have been put in place to protect environment and people. Sometimes those regulatory and legislative guidelines actually undermine each other, so much so that progress is not made, or that one legislative framework may actually work against another legislative framework in a different jurisdiction. So understanding what those regulatory and legislative blockages is very important to our research priorities. We are also keen to deliver to communities exemplars. So giving communities some confidence that post-mining futures do have success in other places. That's not to presume that we can necessarily adopt, but that we apply some of the learnings from elsewhere to give communities and people confidence to adapt some of those ideas. We're also keen to enhance decision-making systems, collaborative systems, systems that work with rather than work for or presume that people necessarily will take science as something to be followed. Very regularly, that's not a success story. We're also implementing technology that we, such as the previous speaker, with tailings, with water resources, pits. How can we apply science to an acceptable outcome for communities and people? We're also looking at supply chains for sustainable business solutions, developing ideas with communities and people about new possibilities, new economic and commercial opportunities derived from assets, infrastructure, or some other post-mining use from those mining activities. We're also focusing on the cumulative impacts of mining and how that can be mitigated or in some way ameliorated in the process of our work for a post-mining future, and understanding that solutions in one place may in fact be detrimental to places further away in a region. And finally, demonstration and data solutions, actually being able to demonstrate and practically apply our research to assess whether in fact it is useful, acceptable, and potentially able to demonstrate why regulatory or other frameworks might want to change, or some of the guidelines that currently are not enabling change to advance as quickly as some people would like. So the way we are undertaking our work is applying projects and calling for projects from communities in 8 hubs across the nation. Those hubs have emerged and they're really coming together on a regional basis of places where mining has been or is a very important activity. Those hubs, some of them are the big standout communities and regions which are very, very productive and very important to the Australian economy now. But there are also other hubs, larger regions where mining was previously very important, but now those communities are either living with abandoned sites or living with large mining assets that are no longer operational, but rehabilitation or satisfactory solutions to the absence of mining have not really been well addressed. As I mentioned before, stakeholder engagement is absolutely at the centre, and it was made very clear to us at the beginning of the Cooperative Research Centre by both the partners and also the government sponsoring us, that stakeholder engagement was to be at the centre of all that we do. Consequently, the programs and the research activities we do, we endeavour to do with community partners and industry. Ensuring that our activities are integrated and that First Nations and communities are at the centre of this is a priority of this CRC. Our focus is through, as I mentioned, the hubs, the stakeholders, and also the researchers, but also taking the research in a different way to what is traditionally the academic mode. That is being very academic oriented, putting our outcomes and research findings into academic papers that are probably not easily understood or necessarily useful at a community level. So the impact, ensuring that people on the ground in the communities where these activities are being focused and centred are indeed easily understood, that they are a part of those communications, and that the impact is indeed understood and easily translated into everyday environments. So our translation communication of research is in a multiple different media, but the focus and the emphasis is on plain language, on easily understood, not great long reports that sit on shelves. It's very much about being easily understood and easily translated to everyday language. We are now almost 2 years into the program. We've undertaken 21 foundational projects. Those projects were very much about pulling together information that is already known across Australia and internationally about mine closure, rehabilitation and repurposing. And we are now into the next phase of research, which are longer projects, probably 3 to 5 years. And these are building on the foundational projects and I guess taking repurposing to the next level, where we're applying some of our research and actually putting in place some of those findings in situ. So any further information or anyone that would like to contact Guy, who is our CEO, I know that he would be very pleased to hear from you. I'm sorry that he's not here tonight, but we are very much open to international collaboration, and we're very keen to collaborate across the nation, across anywhere else that is encountering the same challenges that we are, and perhaps coming up with opportunities to apply some of our findings elsewhere would be a great opportunity for us.
Thank you so much, Fiona. That was a great walk through a big project, 77 partners. That sounds like an ambitious undertaking.
Yes.
There weren't a question directly related to your presentation, but I thought this construct of the Cooperative Research Center, that's something that I think is pretty particular to Australia. At least I know of some cooperative research centers that exist in Australia. And I was just wondering if you could tell us maybe a little bit more about this construct of the Cooperative Research Center. I think it's a government-funded project, so you have sort of initial funding to develop all these projects with the goal of then commercializing some of the solutions that you come up with. So maybe if you could say a little bit more about sort of the amount of funding, how long the project runs, and also how international partners could sort of join in at this stage, and what you may need, you know, in terms of technology, or so. I think that would be helpful.
Thank you. Cooperative research centres are a wonderful opportunity for researchers, because they're usually projects that are much longer running than just the usual 2 or 3 years. So it means that you can actually be courageous and put in place research projects where you can actually see the results of your work and apply them. The cooperative research centres are usually only funded if they are actually tackling a difficult problem. I won't say necessarily a wicked problem, because that's not always the case. And there are different cooperative research centres in Australia, but certainly we would consider ours to be a very, tricky, difficult, challenging problem. And I think that's probably an international accepted conundrum. But they initially, the way they are funded is that mining company or partners put up commit to an amount of money each year for the life of the projected cooperative research centre. In our case, it's 10 years. I don't think there's any cooperative research centre that runs longer than that. Usually they're about 4 to 5 years, maybe 6 years. So it really is a tacit signal to us that we have to work hard, we have to work quickly, and we hope that we will be able to see some results of our work before the 10 years is out. Pardon me. So yes, the fund, it comes from industry, but also from other organisations. But not all organisations necessarily are able or in a position to put money into the Cooperative Research Centre at the outset. For example, many Aboriginal and First Nations communities are very, very interested in what we might be able to achieve, but they were not in a position. But they did commit to in-kind contribution, and that is taken seriously by the federal government. So once these, so we put up our bid, and our bid was a multi-million-dollar project, and provided there's more than 51% from partner organisations, then the Commonwealth government will then match that. So yes, it's I guess one of the other challenges of a cooperative research centre, particularly one on a national scale, is that the presumption that what works in one place will necessarily apply to another is not at all the case. So understanding the complexities of a national project such as this is quite challenging. But I guess another advantage of having 10 years to do something is that we are not tied or influenced by a political cycle. So governments can change. And we are relatively, I won't say we are entirely, but well, I think we're relatively immune to some of those political machinations that often withdraw funding or change funding. So that's another reason why cooperative research centres are very appealing. And I guess from a taxpayer's point of view, it's very much about taking good, hard academic rigour, but applying that to everyday language, to everyday situations is a very central part of a cooperative research centre project.
Yeah, wonderful. It's a great tool. I mean, it's a public-private partnership, you know, but yeah, really, really good tool. And is there anything in particular that you would look to for international partners or international collaboration? Is it more on the technology side? Is there anything specific already that you would like to put out to the people who are listening?
Well, I think any sort of collaboration is of enormous interest to us, and I think it's you know, there's because there are the four strands of this cooperative research centre, you know, the people part of it, the technical part of it, and the applied part of it. There are opportunities to collaborate. I guess one of the challenges from my perspective, and I lead the Regions in Transition Regional Economic Development program, is that you know, people don't fit into slots, and how different communities respond to different circumstances, and how we communicate and I guess visualize what change might look like, I think is a really big challenge. So if anyone in this network is working on those sorts of, I guess, futures, visualizing a future, I think that would be of great interest to us. And, you know, we have a commitment in the next round of funding to make regions in transition, and how do we respond to repurpose solutions on a regional basis is really quite challenging, because nothing is cookie cutter. It really does have to be bespoke, and communities are very quick to remind you that, you know, we're not the same as someone else. So understanding how other jurisdictions introduce the notion of a mine closing, and encouraging a community to come with them on that journey, and understanding what it is that the community might want in the future, and how we can work towards that would be of great interest, certainly to me anyway.
Okay, great. Yeah, I mean, maybe some of the Canadians, they are also working with the Indigenous communities. There was also a comment in the chat that from Germany, from the lignite miner RWE, that the stakeholder engagement and participation is really an essential part of a successful mine rehabilitation. I mean, Germany is very densely populated, so I think we have some experience with community engagement too in the process. So yeah, I guess the people who feel called to, they will contact you afterwards. And since you're not part of the panel later, it's late in Australia already. Thank you very much for coming on and jumping in on a short notice. And yeah,
thank you for having me.
Thanks. Yeah, no, thanks a lot.
Bye.
Thanks.
Thanks, Arti, and thanks, Fiona. We will now hear two presentations from Chile, and I would like firstly to give the floor to my colleague Yannick Weiss from the German-Chilean Chamber of Commerce, who will introduce us to the project Eco-Mining Concepts, a German-Chilean network for sustainable mining. So Yannick, we look forward to your presentation.
Thank you, Sophie. Please let me know once you see my screen.
Yes, we can see your presentation.
Perfect. So yeah, thank you, Sophie, for the invitation. My name is Yannick Weiss. I'm a project manager for energy, mining, and sustainability at the German-Chilean Chamber of Commerce. And I will introduce you to eco-mining concepts and how strategic collaboration leads us towards sustainable post-mining. So what is eco-mining concepts? Eco-mining concepts is a network of companies and institutions in Chile and Germany that are focused on sustainability issues. It's a project that has been implemented in 2018 with the support of the German Ministry of Economic Affairs and Climate Action. And we are basically elaborating sustainable and innovative concepts for the mining industry. And we're making sustainable businesses visible and try to position them well. We have an advisory committee of approximately 13 institutions and businesses that help us plan our activities for the year. And we have 30 members from Chile and Germany that are participating in the planned activities. Our activities and member benefits include that we have a web page where we are publishing news and best practices of our members. We have a newsletter for Germany and Chile where our members can publish latest news. We are organizing webinars, exclusive eco-mining concept circles where we are targeting certain topics such as the extended producer responsibility law or circular economy in general in mining. We are promoting partnerships. We do networking activities. So that's basically the basic things we're doing within that project. So what is happening in Chile? Chile is boosting the green economy a lot. They are having sustainability in mining at two levels. Firstly, Chile wants to be the raw material supplier for the energy transition. Secondly, mining is a key sector for achieving national climate goals in Chile, which include the achieving of carbon neutrality by 2050. Also by 2023, 63% of the copper mining industry's electrical energy must come from clean sources. By 2030, 100% of tires used in mining must be recycled. And they want to increase the use of seawater for mining processes by 6% each year, targeting 47% in the year 2031. And they have come up with a strategic roadmap for the next 30 years with some predefined goals within their national mining policy 2050. So as you can see, Chile is very committed to making a change and taking part in developing a more sustainable mining sector. And that's great because on the other hand side, in Germany and Europe, we have a leading position in commitment, looking, for example, at the Green Deal, a plan including 15 concrete actions to make Europe the first CO2 neutral continent by 2050. There's Germany's commitment to achieve carbon neutrality by 2050 as well, which was assumed in the framework of the Paris Agreement and also embodied in the Climate Protection Plan 2050. There's the access to raw materials such as lithium and copper, which are a key to energy transition in Germany and Europe. And in this context, producers and exporters of raw materials become very, very important allies. So we can basically look at a strategic partnership between Germany and Chile. We have a cooperation agreement between Chile and Germany in the field of mining since 2013. We have an association agreement between the European Union and Chile since 2005. There's still some negotiations currently underway to modernize those agreements and to further deepen good trade relations and extend cooperations to new areas as well. On the one hand side, we have Chile that wants to be positioned as a supplier of sustainably extracted raw materials, and they want to achieve national climate targets with the help of technologies and know-how from Germany. And on the other hand side, we have Germany that needs the security of supply with sustainably mined metals for future technologies, and they are able to apply German clean technologies in the Chilean mining industry. So already coming to an end and coming back a little bit to the sustainable post-mining as well. Our last webinar dealt with the topic of reprocessing mining residues for use as a secondary raw material source. So here again, Chile and Germany complement each other very well strategically, because German technologies offer the possibility of refinancing the high proportion of recyclable materials in the tailings in Chile to obtain secondary raw materials, which in turn benefits both countries a lot. Thank you for your attention. If you have any questions, please feel free.
Thank you, Yannick. Yeah, there weren't any questions in the chat now, but so do I understand correctly that this is more for like a strategic dialogue forum, like where you have certain events to kind of inform both countries on the activities and strategic goals in terms of sustainable mining?
Exactly. It's basically the idea to update each other. So our members can, as I've said, publish best practices, for example, take part in our webinars, which we are planning on certain topics that are, yeah, in general interest to most of our members, our advisory board, as well as the public in general.
Yeah, great. That sounds good. And maybe one last question. It's interesting because it's an international, like bilateral project. Is there a specific funding program that sort of supports this kind of bilateral dialogue? Because I think that could be interesting for other listening institutions as well.
Yes, definitely. So the project is in general funded by the Federal Ministry for Economic Affairs and Climate Action from Germany. Our members pay a small member fee, a yearly fee, so we can continue with our project each year, and it's a rather low fee for 1 year, and I believe that yeah, many institutions and businesses might be interested in joining us, since we have some great activities that are coming up for this year as well. So feel free to contact me anytime.
Great. Yeah, sounds wonderful and very encouraging that you know, these kind of activities are also funded. Okay, Sophie, who's our next speaker? Thank you, Yannick.
Thank you, Yannick. Thank you, Arti. We now have another presentation from Chile, and we'll listen now to Dr. Sebastian Fingerhut, Professor in Electrical Engineering at the Catholic University of Valparaiso in Chile, and he will talk about Chilean universities as partners in post-mining projects. And he will introduce us to the project STINGS, an online mine tailings monitoring solution, and the Tailing Academic Group. Welcome, Sebastian. Please turn on your camera and microphone and go ahead with your presentation.
Yeah.
I see you already shared your screen. Perfect.
Yeah, here I am. Thank you, Sophie, for your introduction. Hello to everyone. Yes, I want to...
Sorry, one last question. Could you switch to the presentation mode? Yeah, okay. Perfect.
I don't know which one is one. Okay, thank you for the introduction. Yes, I want to share a little bit experience as a Chilean university working with German or European projects, and yeah, a little bit of my experience, and it matches well with what Yannick presented in the previous presentation. I will, as I said, briefly explain what are universities in Chile, because we are not the same as a university in Germany or in maybe other countries. There is always some special thing you can detect that's different. And then I want to go to two examples from my experience. I want to introduce myself briefly. I'm an electrical engineer. My name is Sebastian Fingerhut. I did a PhD in electrical engineering and acoustics in Aachen in Germany. And I'm at Pontificia Universidad Católica Valparaíso since 2010 at the School of Electrical Engineering. And there, that's the same in Germany as in other places. I have several duties, teaching, research, and I will show that in the next slide. And I'm in charge since a few months of the Interdisciplinary Engineering Center at the Engineering Faculty. And we want, in the center, want to coordinate projects that are interdisciplinary. So that means joining the mechanical engineers, the electrical engineers, the chemical engineers, and so on. There is my email if you want to contact me. Some difference between universities in Chile and Germany, and I want to present that because I know there are listeners from both sides, so that everyone can get an image what if you want to maybe collaborate with a Chilean university, what you have to be careful, or I don't know how to tell it, but what are some of the difference. For example, what is a faculty? In Chile, mostly we have, for example, a faculty of engineering, but in Germany, it's a faculty of electrical engineering or of mechanical engineering. And in Chile, in our faculty of engineering, we have several departments, the civil, electrical, computer, mechanical, and so on. And in Germany, you will have several chairs in the electrical engineering. Yeah, for example, power engineering system, integrated circuit design, autonomous vehicles, audio processing, and so on. That's one difference. So there is a little bit of different level. What we have in Chile in our departments, for example, I am in the electrical engineering department or school. We are 10, 20 professors working in the same building, in the same floor. Yeah. And in Germany, what's my experience? There is a chair, the Institute of Hearing Technical Acoustics, of Hearing Technology and Acoustics. There I did my PhD. And there is one or maybe two chairs or professors. Yeah. What we have to do in Chile, teaching, research, and it's a very hands-on research. Yeah. Administration, outreach, student advisors, and we do also the undergrad and postgrad student advisors. Yeah. And in Germany, it's a little bit different. The professor has the same things, teaching, research, but more as a director, yeah, admin, outreach, but it's advisor of the PhD students, yeah, not normally, not of the master or bachelor projects. And in Chile, we have a more horizontal hierarchy, yeah, and in Germany, it's more the professor on the top, the Oberingenieur, the chief engineer, and all the PhD students, and it's more a pyramidal hierarchy at the faculty. And I wrote down a note, postgrad only if there is a Master of Science or PhD in the department. Yeah. In our department, we have a master and a PhD program. So we have postgrad students, but other departments, for example, at our faculty, don't have those, so they don't have postgrad or research students. What about research funding in Chile? In Chile, it's mostly funds come from ANIT, that's like DIHK in Germany, yeah, the state funds, and also state funds with industry, that's Corfo. Yeah. What about direct research funding by industry in Chile? Almost non-existent, but I remarked it in green, necessary. Yeah. And in Germany, these chairs or the universities have basic funds, but also, and that's the big difference, third-party funds from industry, from the DIHK, Europe, and others. What are the similarities between both universities in Chile and Germany? Research and development projects are very similar. Yeah, we are, as a professor, researcher, highly specialized. We have equipment, we have laboratories. We are very flexible in the project characteristics about budget, duration, intellectual properties, and so on. And we can work as an individual researcher or in bigger research groups. And the example of Australia a few presentations before was very interesting about what can be done. That's the small introduction, because what are the difference between Germany and Chile? And now I want to go to 2 examples. I was working in a research and development project, STINGS, mine tailing monitors. It was a supervision of tailings by an integrated novel approach to combine ground-based and spaceborne sensor data. It was financed by EIT Raw Materials from the European Union, and the main chief partner was DMT, a German company, and some universities from Germany, and some companies and some other partners working together. The idea was, and I'm not going deeply in the project, I want to show what's the collaboration opportunities. Yeah, we wanted to implement a monitoring system for tailing dams, combining geotechnical sensors, remote sensing, some modeling about the stability and some modeling about the water, hydraulic modeling, and interface and join that all in a interface that's the DMT Safeguard. That's the web platform to see the data from this DMT company. They provided the sensors, GPS, GNSS sensors. We installed them on tailing, and we visited the facilities. And the nice thing was we had in Chile the tailings. Yeah, in Chile we have 700 tailings. Several of them are abandoned. Only, I don't know, 15-16% are active. So there are many tailings in Chile where you can do a research and development project. In this case, it was an active tailing where we did the testing of this sensors. The context, and what I want to show my second example, because this first example is a project that finished 1.5 years ago and shows how a German or European research project can also involve, in this case, a Chilean university working in a Chilean mining facilities. My second example is about inter-university collaboration. In this case, it was an idea of several colleagues. What was the context? Several researchers were working on tailing at different universities in Chile, and working on different topics: modeling, geotechnics, fluid mechanics, sensors, earthquake, closing, post-mining, etc. But we know each other, but we have no real contact. So there was a few years ago called, we were meeting as a group, we start meeting, and Vale published a request for information future of tailing was the title of this request for information. They wanted to know around the world who is working on tailing, on what topics, and they wanted to share ideas, and they wanted to finance maybe some projects. And we wrote a proposal, research from different universities. We know each other from meetings, but we didn't work together. And we called our proposal Open Tailing Engineering Research Laboratory. We had the opportunity to dream what we want, what we need, what the industry in Chile needs. And looking also some examples we heard from Sweden, we wrote a proposal. You see on bottom the different 12, 13, I don't know, researchers from 4 universities. We are very open to work together. And we proposed several work packages. And the funny thing is our diagram here also looked like a tailing dam. That was not the original idea. And we have capacities in several topics. We made a list about what we can do, what we could do in the future. And we proposed that to Vale. In this case, it didn't, we did not get the financing of this proposal. It was a big proposal. We were thinking also about maybe 10, 15 years with big budget for a typical Chilean project. But what we want to show, or what I want to show, it is possible to join researchers with different with different, how do you say, from different science, to work together and write a proposal and for an international call. I want to come to some finishing. What does it mean to work with universities in mining? At universities in Chile, we are flexible, we are open and interested in getting invited in working in research and development projects. We can be very dynamic and work in short or long projects. We know as local Chilean, we know the Chilean mining, we are working with mining companies. We are, as I showed, several experts in several topics. We do research and development, and something that's very maybe funny, we speak English. In meinem Fall, ich kann auch Deutsch sprechen, was auch hilfreich sein kann. But speaking English or Germany is in many cases a very important thing to consider in this project, because not everyone in Chile in the mining sector is speaking English. So working also as a translator is important. And my message for you is, you as a Chilean mining companies that maybe are attending this webinar, but also for foreign mining companies, for foreign universities and research centers, for engineering companies, for service providers. For all of them is this presentation to show we can be and we want to be partners in projects we can imagine for the future. So that was my presentation. Thank you very much for your attention. And again, there is my email address if you want to contact me later.
Thank you very much, Sebastian. That was quite interesting. Do you know which was the funding program for this DMT project? Was it industry funded or was it a government?
It was from EIT raw materials, from the EIT raw materials.
Okay, European. Yeah, that's good to know. And the second one, the Vale one, would have been sort of a company call, right? Like a challenge put out by the company, by the mining company.
Yeah, like a challenge. It wasn't, a call, a request for information. It was not very clear what they wanted, but asking what they want. We want to know who is working in tailings and monitoring and many topics of tailing, and they took probably they had a lot of proposals because they took very long to answer, but then they presented which were the selected projects, and it was a drone surveillance projects. I don't know exactly what it was, but yeah, it was a worldwide call.
And do you know where it was published? Like, is it sort of on the company website, or how you learned about it?
I don't know exactly. I have the information because I probably got an email. So for more information about that, you can contact me later. I will probably find that information.
I think it's just interesting because I do think it's a bit of a trend that also mining companies put out sort of these requests or challenges to look for expert information and project.
Yeah, in Chile, some other companies also are permanently offering or yeah, inviting to this proposals to some projects.
There's a comment in the chat from Bertram Heinze that they also participated in the Vale request from Brazil. Bertram, did you want to make a comment on your experience with this type of company information request? Then you're welcome to unmute yourself and just give a small contribution. Doesn't seem to come on right now, but maybe he will come on later on. One last thing was, I know that in Chile, they have a pretty sophisticated roadmap for sort of transforming the mining sector, which is geared towards digitalization and so on. And we kind of look up to Chile for this multi-stakeholder initiative, how this roadmap was initiated. And does post-mining play a role in this roadmap? That was just a question that came up.
Yeah, I have looked at this roadmap a few years, 2 years ago. I don't know exactly, but yes, it's a very, it includes, yeah, everything in related to mining. Yeah, also that's, I think, very interesting of this presentation from the colleague in Australia about communities. Yeah, of course, being green, yeah, eco mining and the circularity and closing is a problem because we, as I said, we have 700 tailing deposits and many of them are abandoned. Yeah, that means, you know, there is no owner. Neither the state, neither the state is the owner. So the state is in this case responsibly, maybe, but yeah, and we have earthquakes. Yeah, that's one of the problems in other countries. Tailing dams are maybe where it's raining, it's a problem because it's overtopping. In our case, we don't have so much rain in the places where we have the mining, but we have earthquakes. Yeah, so the problems maybe are very different, but we need engineering, and not only engineering, but all these other actors to work together in this. Communities are very concerned and don't get much information about what is happening in the tailings.
Mm-hmm. So again, community engagement and communication with stakeholders seems to be a thread for sure. There's one question from a participant. How do you describe the local access to Chilean mining companies? Is it difficult or easy?
That's I know only the Chilean case, but we have the big mining companies. We have medium and we have small, and I would say it's not a big problem. You have to know what project do you want, and the smaller companies are often more open to open the doors to do some projects. In the presentation of Yannick, in the left corner was a small new or information about Minera San Pedro is opening for eco mining projects. Yeah, so that was very interesting because there you have some, in this networking, there you have some opportunities to do projects with some companies. It will be probably not the big ones. Yeah, there you have to probably look for these calls or look exactly in the roadmap, but there are the small and medium companies that are, I would say, and it's my experience, very open to research and development projects.
Yeah, and also just to say here, maybe that the Chilean German Chamber, of course, is also with the Competence Center for Mining a good partner to contact companies. And then there was one last question: was the Vale call for projects before or after the dam collapse in Brazil? After. Okay.
It was after.
Yeah, interesting. Or maybe
it's of course a consequence, I think, and very welcome to look what are researchers and companies doing for this project, as for these problems. Yeah, so we and for our proposal, it was important the name open. Yeah, we want to be open. It's like in Australia, cooperative. We want to be open. Everyone who wants to come, yeah, you have to probably sign something, but it will not be a closed research project. Hopefully with many companies and service providers and universities, national and international. So the dream is still there.
Yes. So maybe who knows who's listening today? Maybe you get inputs and the opportunity to work on this. I know BHP also had a big challenge on tailings, so there's obviously some dynamic in this topic. Okay, thank you very much. We'll see you also on the panel in a little bit, and I'll hand over to Sophie for the last presentation.
Thank you, Arti. Thank you, Sebastian. And to all participants, don't forget to write down your questions down in the chat. And last but not least, I would like to introduce our last speaker, Dr. Tobias Rudolph, Professor for Geomonitoring and Post-Mining from the Technical University Georg Agricola in Germany, which is also partner of the German Mining Network. And Dr. Rudolph supported us in the organization of this webinar. And he will talk about how post-mining enables the mine life cycle. So welcome, Dr. Rudolph. We look forward to your presentation.
Yes, Sophie, Arti, thanks a lot for introducing my person and also my presentation, ladies and gentlemen. I appreciate the chance to talk to you today on the topic of post-mining and how post-mining enables principally the life cycle, the mine life cycle. And I think I will elaborate a little bit further on what especially Fiona said earlier today, on how to build up a participation and engagement with the public. Before I start with my little talk, let me quickly introduce my university. We are located in Bochum. The Technische Hochschule Georg Agricola is really, because it's Bochum, it's on top of a big coal reservoir, and we are now facing the challenges of post-mining. Is really the heart of post-mining, if you like. And 7 years ago, a research center was founded looking in various aspects of post-mining. Started with the perpetual tasks and the mine water management, then geomonitoring and post-mining. We also look from a preservation industrial heritage perspective on material science, so what to do with the former surface installations. Can you use them and you can keep them for the public? And the last topic we are looking at is reactivation and transition. So what to do if you close an entire industry and how that affects a region, what you can do here from an economical perspective. So if we think about post-mining and how to close the loop, let me start with an example. Picking up now the current discussion on circular economy, and let's have a look at, let me say, an everyday example, the usual mattress we use every day. If you nowadays produce it and use it, you have a maybe a very straight process. You produce the raw material, you manufacture it, you trade it, you consume it, and at the end of the process, it's waste and you are no longer using it. But if you look now at circular economy, you will kind of close the loop here in terms of recycling and reusing it. But due to the fact that some parts in that cycle are, say, not longer part of the cycle and gets an external utilization, at one stage you need to have still raw materials fed into this cycle. So it's quite important that also in the future we have mining industry producing the raw materials even for such everyday example. And if you take this in your mind and take that further, if you look at the, maybe some of you know it, a great example of the Geological Society of London, what geoscience in the future means, you'll see to the left corner that even mining is part of our future development. And if we consider this and we see the changes in public perception, we need to do better in our mining processes, especially in the post-mining phases, and to create more participation and engagement with the public to ensure that mining operations are in the future still doable. This thought is not new, if you like, and if you look 500 years back and you go back to Georg Agricola, maybe some of you know, he's the founder, if you like, of modern geology and mining. He wrote a famous book series, Metallica. Say most of us working in the mining industry know that book. And he's the first person who is documenting, let me say, public criticism on mining-induced damages. So already 500 years ago, mining was in conflict with public acceptance, public engagement. He also built in his book first approaches on risk management, also a topic which is nowadays quite modern, and surely, which is not so much part of today's talk, he looked into occupational safety and health of such mining processes. So, looking at a mine life cycle, looking at the engagement is not something pretty new, but what is now challenging us is that we most of the times think about of a linear process in terms of mining, but on the other side we see that the approaches, legislators and NGOs towards climate change and environmental protection are giving us also hard times. We also have new emerging technology, the fourth industrial revolution and digitization, which is an additional challenge for us. So bringing this together, we now need to rethink mining. And I think by looking at the post-mining processes, we can do better in the beginning of setting up a new mine project. And my, let me say, innerst motivation is here that geomonitoring provides us here a game changer. Because if we consider the mine life cycle as a loop, and we are closing the loop, and we are running a monitoring process all around the different phases of the mine life cycle, we can increase dramatically the public acceptance, and we provide engagement with the public. And by even taking external factors into account, like climate change, we provide a full process understanding, and we bring that even to risk management. We just heard the presentation of Sebastian that he was saying that heavy rainfalls affect the tailings in Chile. Yeah, this is external factors we need to consider whilst monitoring mining processes. And how we can do that, I want to show you now in a short example, short project example, where we were involved here locally in Germany in some success monitoring for a renaturation project within a polar region, so a region which underwent massive subsidence due to underground mining. And we looked at what happens at the surface, established a highly integrated geodata workflow, geomonitoring workflow, where we installed ground-based soil moisture sensors, went regularly drone flying to capture the changes in the landscape, and we saw immediately the effects of droughts and rainfalls within that region, and were able to discuss with the project operator how this area regionally develops. Went even further and introduced satellite data to that project. Here we use the Copernicus data of the European Union, free open geodata, and we use the data to even extend the monitoring and having a time series to further investigate the effects of climate change. And you will see here that we had, within the 6 years of monitoring, 2 drought summers, which had some, you might not see that on the picture, some subtle effects on the polar region. So taking these 2 examples of monitoring within the same region, surely, it brings me to the point that you need to monitor it. And if you take even preferably open geodata, for example, EU Copernicus satellite data, you can create quite a transparency on what happens on the surface. And this helps, we say, in public acceptance, as well as for you as an industry for designing and planning of your next steps in terms of mining. So closing the loop now, I think post-mining is really a game changer, because at the end of current projects, we learned quite a lot on what happens to mining affected areas. And by building that process understanding, we can do better now within new and modern mining projects. And if you consider geomonitoring as a continuous process here, run full data fusion approaches, you are within a kind of full 4D analysis. And by that, you are really building a process understanding. And then, let me say, if you take that understanding, you really serve the social responsibility. You can build communication, levels of communication and participation. And by taking, let me say, the learnings from post-mining and the geomonitoring, you are really, as a company, in your social license to operate. And therefore, I think post-mining, so the topic of today, is really an enabler for future mining projects. Thank you for having the chance to talking to you, showing our approaches and a quick glimpse on our research projects. And I'm quite keen on getting your questions and being part of the plenary discussion. Thank you very much.
Yeah, thanks a lot. There haven't been any direct questions now, but just invitations to learn about your experience. So you can look into the chat to look at the email addresses, or if Fiona is asking, to connect. So there's already a good networking opportunity. But I really like the approach that you take on sort of looking at the potential of sort of changing the game on post-mining to improve the public image of mining, and to therefore also, look at post-mining really as an enabler to secure the future of mining projects. And in that way, it's a very circular view. So thanks very much. And I think we will discuss a little bit more in the panel. We had the comment from Bertram Heinz, who was also part of the Vale call, and he said he would like to share his experience. So I suggest, while we pin the speakers for the panel discussion on the Zoom screen, Bertram, you're welcome to share with us your experience from the Vale proposal.
Okay. Thank you very much. Can you hear me, Ben? Well?
Yes. Mm-hmm.
Yeah, I just wanted to share. I mean, we saw this request for information appear even with partners in Asia, and so it was really international. It was some kind of a huge. It was organized by Stratalis, so they did it in the name of Vale, and I had some closer discussions with one of the guys who kind of was a former colleague of mine at Vale. So I tried to figure out how serious this was, and it appeared to me that it was really more like a information gathering exercise rather than really getting to the point of real projects, even though they had in the end some projects selected, but it was a lot of let's say gathering the information, yeah, which is I think very important and shows very well that they are very, very concerned, and they have a lot of let's say technologies that they now implemented here. I'm living in Pará. Pará is one of the states where Vale has the biggest mine in the world for iron ore, and one of the centers for geotechnical monitoring is here. So they certainly implemented a lot of these modern day technologies, from robotic total stations that measure prisms on the tailings surface in order to monitor permanently any movement in the dam through INSAR and to all other stuff. We offered in the request for information, together with the German company Alberding GmbH, we offered to install GPS monitoring stations that can measure dam safe, the structural, let's say, structural movements of the dam up to down to millimeter, let's say millimeter level. If you see this in a post-processing mode, meaning every 4 hours, or you would get an information how much a sensor placed on the surface of the mine tailing dam might have moved in terms of millimeters. Yeah, and one could combine this the GPS or GNSS geomonitoring with, let's say, also real-time mode, which is much less precise, more in the centimeter range, but you have an instrument simultaneously working for you 24/7, automatically observing any let's say critical movements in the dam structure. And coming back to the conversation with my former colleague who works there at Stratalis and was part of this initiative, he told me that yes, it was considered interesting, the approach of GPS, but only for high risk areas. So where you would immediately or where you would suspect the dam would break most likely. Yeah, so you have dam structures that are 300 meters long or 600 meters wide, and you might have a point where you consider this as the most dangerous or most easy to break. And so in that sense, they gave us this return. Why I wanted to really specifically comment, because Sebastian said that in Chile, dam structures are less affected by rain than they are here in Brazil. Heavy rains can have caused again and again problems. Just recently in January, an overflow of a dam in Minas Gerais area. There was no dam break, but it was an overflow due to heavy rains, and so the water washed away part of a highway, or washed over a highway, so it was already pretty close to being very, very dangerous. But in Chile, you have a lot of earthquakes, and if you look at GPS stations, you could use them as not only to monitor the dam structure, but also the intensity of earthquakes. So due to the intense high rate sampling rate that the GPS station has, and its movement, its shaking during an earthquake, you can also refer back to, let's say, intensities, ground shaking intensities at the location. So you have a very versatile instrument. Yeah. So.
Okay, great. Thank you very much. I just didn't want to extend it for too long because we also still have our panel discussion. But thanks a lot for coming on and commenting on your experience from Brazil.
Thank you.
Okay, so now we have our panel discussion. I think the questions and answers, we basically worked through them after the presentations. I don't see any open questions in the chat. If there are any questions pertaining to our discussion, you can post it in the chat on the Q&A. And the speakers of the panel discussion, Tobias Rudolph and Sebastian Fingerhut and Jens Krumm, if you can put your video on. And I think Fiona is also still there. So if you want Fiona spontaneously join us, you're welcome to do so. I kind of followed the presentations and the discussions along, and I thought it was really interesting to see that when we talk about post-mining and reimagining mining and post-mining, we need to look at certain areas. One is technology and innovation, and I think we heard a pretty interesting example of an innovation in this area. But what's interesting again is that also in post-mining, we don't just need technology and innovation, but we also need collaboration, multi-stakeholder collaboration, international collaboration. We need community engagement, taking the stakeholders along, and also changing the public acceptance of mining, and that relates to stakeholder engagement. So I think this sort of, as I see it, it's kind of summing up the challenges, but also, sort of the areas that we need to look at. First, looking at technology and innovation, we often speak about the valley of death for innovations. And all of the projects that were presented today, they're at least in part funded by governments. And product development or technology innovation is part of most of your programs. So I'm wondering if you wanted to share something, and I thought this was for Mr. Krumm, maybe to start in terms of bridging this valley of death of your innovation. Is there a sort of a plan to commercialize the technology, and any challenges or maybe lessons learned or things that you want to share about the challenges of bringing new technology and post-mining into the market?
Well, yeah, interesting question. Of course, that is one of the triggering questions which supported us to go for that research project. The point is actually that the technology to measure metals in tailings has been carried out already as a service. So we actually did that, not we with the partners which are now running that research project, but a couple of years ago with a current geotechnical service company, even in Chile. And we measured the stuff, so we got the data, but as we were a paid service company, we could use the data. We handed over the data to the owner of the mine, and that was the end of the story. We never get knowledge about what happened with it. But our approach now is to close the gap and to apply theoretical, statistical standardized approach which has been funded for primary deposits and to combine it with a new technology for secondary deposits. So that at the end of the day, once, for example, if you want to open a gold mine somewhere in Africa and you have a resource statement according to a South African standard, you can go to a bank and you get money for it, a loan, because you can provide security. Once I want to go and to remine a waste disposal, as we have here, no one will spend a penny. But once we have such old tailings where we do not know, where there is no owner anymore, everybody is calling for the state to fund it. If you do something like we propose here, in order to find out how much of which metal, either it is a valuable metal or a competent, a pollutant somewhere, is where in this stuff, with which level of confidence, then we can estimate not even only the costs to remove the stuff, but even the value of what might be in there. So for example, even in such a case where we have a tailing which will cost the state $50 million to remove it and to remediate the area, once we have the stuff inside, maybe tin or copper, which brings us 30 million on the market, then hey, we have a win-win situation. We can reduce the cost at the end of the day of the public, for the public funder. That is one thing. So normally we tend to look on such a problem from the one end or from the other end. The one end is black, the other end is white, but it is gray. And that is actually the first step in this chain of for a feasibility to define, according to international standard, what is in there. And that is actually our approach. You can use it commercially, if so, maybe in Chile, a lot of tailings with high copper contents, which are 50, 60 years old or older, or even in industrial areas where the mines has been abandoned and this waste disposal is supposed to be removed. That is actually our approach.
So the main target would be to basically have a service with the technology and to sell it as a service to governments who are dealing with these legacy mines, or is it also something that could be interesting for mining companies who are, already plan in their post-mining activities before they even start the mine? So as part of the mine design to sort of have a technology like this available, do you think that could be also an area of commercialization?
Sure. Yes. No.
So, and do you think you will be able to sort of achieve the commercialization of the technology within the project that's funded, or do you see sort of a risk in getting it to the market? Because it sounds great.
First of all, we need to show evidence that this, what I've been explaining, works. That the technology works has been proven, even in Chile. And now we combine it with a theoretical approach or the mathematical approach of a standard in order to provide a resource statement. And that is actually new. And let's see, we don't know what will be the outcome, but we are very confident that it can work.
And one last question, do you have specific needs? Like, is the consortium pretty much, working well, or is there any sort of need that you would have, that you're looking for in terms of expertise or something that you could use that could help you for advancing the project?
Not at that stage where we are at the moment, because as I carried out, technology is working, the theoretical approach is working, but at the end of that chain, or of this first step, what would be the next one is the feasibility, the economical assessment. Does it make sense? Well, how can I make money? Can I save money if I use the technology once I'm going to remove an old tailing. So that is actually the next step, the commercial assessment. So that is, we have that in mind, and but it hasn't been carried out yet. First, we need to show evidence that our, let's say, engineering approach is working. Then we go to the next step.
Okay, yeah, that also I think makes it a bit more clear on where you are in the project. So anyway, I wish you the best of luck with the project. Hopefully, we'll see some innovative technology coming out of this. Tobias Rudolph, what's the sort of the state of commercialization of your project or your innovation in the geomonitoring? Do you see a business case there in the future?
Oh, Arte, yeah, absolutely. Deploying open geodata, and especially deploying open satellite data is really a big business. Currently, the developments are so quick that we are not yet there to have a fully established business models here, because say only some people really are able to fully integrate these different satellite sensors to build a complete story. And what we learned also on our end is, and that maybe still a challenge for commercialization, is that even though the satellite data is freely available for all of us, we still need to have in situ validation, being at the ground at these places to understand what the satellite sensors, different satellite sensors are telling us. And I think in the future, also where we are trying to work on is in the future, let me say, deploying machine learning algorithms to bring together these different levels of data, of open geodata. This is really the basis where we can start really of having fully commercialized business models and products here available.
And this is not limited to any type of materials, right?
No, absolutely not. Yeah. And I was going further to the statement of that, what was it, Heinze, the colleague? Yeah, there's more than just doing some measurements in terms of height and stability. If we think geomonitoring here and deploying different sensors, this is a fully integrated approach. Yeah, I'm saying always it's a big jigsaw. Yeah, we need to put together different pieces. Yeah, to build the entire picture. Yeah, and even for stabilization monitoring, you can use, let me say, additional data like vegetation indexes or indices to understand what the plant is doing, which is also an indication on stability. So it's really a big story. Yeah.
And do you think that mining companies are ready for the level of transparency that the technology would bring?
Well, I think at one stage they will have a hard stop, let me say, on this, because the data is freely available for all of us. And if there is a smart NGO or a smart person, yeah, being able to use that open geodata, yeah, people can build their own process understanding and then say, and go to the kind of mining company, say, well, I looked at the open data here, that's the story, and you are telling me something different. So I think mining companies, and also there we can help as research agencies or institutions, need to pick up that chance quite early on, to be ready for that time. Yeah.
I mean, definitely. I think otherwise there will be sort of surpassed on the right, like we say on the German Autobahn,
sure.
where I think mining is really at a critical point where mining companies really have to look very closely at the public perception and sort of how they position themselves in the socioeconomic context they're operating in, and not just look at stakeholders and communities in their immediate environment, but sort of look at more broadly how they can position themselves more as value creators rather than shoveling a lot of dirt around from A to B, right?
Absolutely, fully agree.
Yeah. Fiona, maybe real quick, is there any specific lessons learned from Australia in terms of commercialization and how to bridge the valley of death in innovation? Is the collaborative research center a good structure to achieve that, or do you also face this kind of challenge?
Thank you, Adi, but I'm not the best person to ask that. I'm an economic geographer, but I can't see why there wouldn't be an opportunity through the CRC if able to do that. But I'm not the right person. Guy's probably a better person to know who does that.
No problem. But we definitely look forward at the innovations that may come from the research center, especially if you start collaborating with some of the great people who've been here on the
and
panel.
Certainly there have been examples of other CRCs where they've been spin-off. They've actually spun off from the university sector, so it's not without the realms of possibility. It's just that what I do is definitely not that.
No, that's great. I mean, I do think that we need to see that we can hopefully get some of the good ideas and these approaches that we've seen here today implemented, so they have an impact on the industry. So that's where sort of my question was heading at. Maybe in terms of stakeholder participation, being a large consortium, maybe there's something that a lesson learned that you could share, because I think there is a trend towards collaborative innovation, open innovation, and in mining, not just in post-mining, but in general, where we try to use these collaborative networks to really, push for the innovation that we need, because we need to get ahead of the game, and time is not working in our favor, I think. So maybe there's something that you...
I think there is, certainly in my part of the CRC, there is a tool that's being developed about, how do you start that conversation with a community, and at what point do you start that conversation? I mean, how do you manage expectations? So there is a tool that we're beginning to talk about where, what are the questions that we need to be asking of the community, and how do we actually broach with the community that they will have to think about another future, and how do you actually give some imagination to the future? So that is something that we are trying to work on, and it's without trying to sort of pigeonhole people or places or communities. That's the challenge.
Yeah, nice. Maybe some scenario work, could come into play there. Okay, we're at 5 o'clock. It's always, panels always run really fast. But Sebastian, maybe you have also something to share in terms of lessons learned with bilateral collaboration and sort of bringing researchers together, or bringing international universities and companies together in terms of funding, a message that you want to
very
share.
Briefly. The Stinks project I presented with DMT, this German company, opened another collaboration opportunities. I'm working on other research projects too. And we are still working together and writing proposals. And they are also interested, of course, as a company to come to Chile to sell their services, their products. And as a university, we are helping them. Not in the business directly, but I see we are partners, and and we are universities, we are researchers, we also have the task to do outreach, and as Fiona told, spin-off companies can come out, and all this is very important from the university side. One question or comment before I also wanted to talk about is about you asked Arti about the innovation, and probably everyone knows here mining companies are very traditional, and innovation is not directly what they want to do. They always say, I think it's probably the same in other countries, show me the other company is using it and I will test it too, or I will
first
buy
to be
it.
second. Yes, everybody wants to be first to be second.
It's always the same. But also, as Tobias Rudolph told, satellite data is available and other data is also available. And the artificial intelligence, the machine learning, as he told, is opening a new approach too. Yeah, Facebook or Google trained their models with millions of faces and pictures that all are online. We don't have so much millions of satellite images, but we have images from the last 20 years, and we have data, not so much, but the models are trained. Colleagues are working on that also in vegetation, and there are the free images, but there are commercial images too. So I like engineering because we are building on knowledge of previous researchers and developing in the edge of technology, and hopefully for that's the big umbrella of this meeting, eco mining. Yeah, to be more aware where we are, what we want, and how much we want, how much we need, and to be careful. I mean, we are going forward, but also we have to be careful. I think that's very important.
Yeah, thanks a lot. And I mean, who knows, maybe if we have another webinar on post-mining in a year or two, we will talk about artificial intelligence and talk about, different technologies. Yeah, I think we're coming to the end of the webinar today. I think what really was becoming clear in a nice way was that we have different solutions that are being developed in universities, in companies, in different types of consortia, but that we do see that collaboration is key, and that there's great benefit in also collaborating for companies to collaborate with research centers or universities and vice versa, and that we need these kind of multi-stakeholder and international approaches to really change the game also on post-mining. So I think this could be a good message, and I really hope that this webinar may have brought together some new contexts, and that there's some new nodes in the network that can start talking and maybe collaborating. And with that, I think we can wrap up, and I would give Sophie the last word to kind of close our meeting today. Sophie.
Thank you, Arti. Thank you to all the speakers.
Thank you all. Yes.
Thank you to all the speakers for the very interesting presentations, the panel discussion, and also big thanks to all the viewers from Germany and all over the world. Thanks to our partners of the German Mining Network. I just want to add, don't forget to check out our website, germanmining.net, where you can find a summary of this webinar in the next days, and also stay informed about our network activities, the next webinar, and can sign up for the newsletter. Goodbye and have a nice day.
Thank you. Goodbye.
Bye. And we're also on LinkedIn, so people can also go on LinkedIn to find our group there. Yeah, and I hope a lot of you will connect afterwards. Happy networking.